and then I'll do a quick introduction and then pass it over to you. Yeah, so welcome everybody to the department seminar series for this week. This week, the seminar series is being presented by the Durham RIOT Club. The RIOT Club is focused on sharing tools for reproducible, interpretable, open, and transparent science. So this week, we're really excited to introduce Dr. Niklas Johannes, who will talk about data visualization in R. Dr. Johannes is a behavioral scientist who studies how being connected to devices, to digital technology, social media, have effects on our well-being. This is a really important and exciting and a relevant topic. I think it's very interesting research, so I really recommend that you check out some of his publications. But today, Dr. Johannes is going to be talking about, making graphs, visualizing data in R. So he received his PhD in behavioral science from Radboud University. He's now a postdoc at the Oxford Internet Institute, but today he's going to share some of his R programming skills, and hopefully we'll leave today with a better idea of how R works and how to make some really pretty and useful graphs. We're going to learn about the basic principles of visualization. We'll get an overview of R and ggplot2, the structure of it, and how the coding works. And then he's going to show some examples of how to graph some specific models. So just a little housekeeping before we start. Please use the chat and the Q&A functions to ask any questions that you might have during the talk. Just keep in mind that the chat and the Q&A are visible to everybody, and that we'll take time to answer some of these questions at the end. And then finally, the materials, the slides, and a recording of this talk will be posted to the Durham RIOT's OSF page, and that'll be shared later. And then the materials are also available on Dr. Johannes' GitHub page. So without taking up any further time, welcome and thanks for joining us.
Right, well, thanks a lot. Let me share my screen. Everybody see this? Yeah, sounds great. Yeah, thanks, Ron. This is the first time I get one of those introductions. Feels weird, especially the Dr. Johannes part. So it's in the chat, please just go with Niklas. That's fine. Oh, it still feels a bit strange to be called like that. Yeah, so my name is Niklas. As John said, I'm a postdoc at the Oxford Internet Institute. I research the effects of media use on well-being broadly. And in that process, I have used R quite a lot and also visualized quite a lot of data. So the idea today is to give you a primer, a basic primer of how data visualization works. So what can you expect from the talk, from this? So I just thought that a lot of you, or many of you, might be new to R or might be familiar with R, but are somewhat new to data visualization in R. So I'm going to give you a basic intro with, it's not that, I mean, I'm saying little code here, but there is some code, because the idea is that you can download the slides afterwards and just copy paste the code into your own R scripts and play around with them. So you can produce some graphs relatively quickly. After this, you should be able to go ahead and produce plots, but you shouldn't, and I don't mean this in like a facetious way, but more in a, hopefully that's just gonna trigger a bit of an appetite to get into data visualization, because you can do so much more and way prettier graphs than the ones that I'm gonna present today. And there's only so much you can do in 45 minutes. All right, then as for the outline, I'm quickly going to talk about why visualization is important, which is probably music to your ears because you're here. Some basic principles of data visualization, and there, again, it's not like I study design or something. There's millions is a lot, but there's a lot of books out there on the principles of how to visualize data. And I'm just going to give you an overview of a couple of principles that I find useful or that I have to remind myself when I make plots. Then afterwards, why R and ggplot2, plus a logic of ggplot and how it works. Afterwards, a couple of basic examples of how I use ggplot in papers, for example, to mostly how to visualize distributions and difference between means. And then we should have 10 to 15 to 20 minutes for questions. All right, why is visualization important? Well, if you're like me and you read a paper, at least that's how I do it. I get the paper, I look at the abstract, and then I scroll down to the figure. Because it's just easier for human beings to extract meaning from patterns and like visuals rather than tables. And in my own, when I write papers, I try to avoid overwhelming readers with large tables with a lot of numbers. It's also how we operate. We recognize patterns and trends. And it's just, in my view, easier to understand, especially if you model something to show people rather than give them a number which can feel quite abstract. But that also comes with, okay, maybe huge is an exaggeration, but it comes with responsibility, and I'm gonna get back to that. So why should you visualize this? This is sort of a, like anyone who talks about data visualization uses this example. Is, I think it's French, Ernst Combs quartet. And the correlation between those variables is always the same. And that's something that we all learn in our undergrads in the first couple of semesters, that we should always, like the process of research involves exploratory data analysis. That's the first step that you should take if you get new data, is to have a look, like literally have a look at the data and not just inspect the, I don't know, where you store it, maybe the Excel file or the data table view in R. This principle has been, say, advanced, extended by Alberto Cairo in the data source dozen. And as you can see here, it's just taking this to an extreme. All of those variables have the same means and standard deviations, plus the same correlation between them. So I think from a first paper, I didn't look in the beginning. So I wrote up the paper, I analyzed the data, but I never did any data visualization until I found out, oh, there's a couple of outliers. Or like mostly you do this as a first step just to see whether your data makes sense, whether there's impossible values, stuff like this. And I think that's just, it's so much easier to discern that if you visualize the data rather than getting summary stats and just looking at those. So I talked about responsibility. At the bottom here, you see a link to Reddit page, and I highly encourage you to check that out, because there's really some gems there of poor data visualization. This is an example from Fox News. I think that was 3 months ago, 4 months ago, made quite a couple of headlines. What's wrong with this? If you have a look at the y-axis, it's like interesting decision in visualizing this and plotting this. Goes in 30 steps, all of a sudden a 10er, 30, 30, 30, then 50. And in this case, I don't think it's particularly harmful, because I cannot see any systematic intent to deceive here, but that can become a problem. For example, in the presidential elections in Venezuela in 2013, this example is from, again, from Albert Cairo, from a paper that I encourage you to read. It's quite cool. It's sort of a follow-up to this famous, was it book in the 80s, How to Lie with Statistics. And he gives a couple of examples how it's quite easy using graphics. If you look at the third point, in forms that are inappropriate, that we distort the data. So if you just look at this graph without the numbers, you think that election was a landslide, but it clearly wasn't. It's probably within a margin of error. And then you're probably going to tell yourself, well, but how does that apply to me? I'd say this is a typical example in psychology. And don't worry, hopefully the rest of the graphs are not going to be as ugly. It's just base ggplot too. But if you have a typical case where you have a control and treatment group, if I present the paper on the left in a paper, sorry, if I present the panel on the left in a paper, never mind that there's no error bars for now. You're probably going to think, okay, this might be a sizable difference. You're probably going to speculate that's probably a 5-point Likert scale, something like that. So that seems like quite a difference. But if you look on the right and it had been measured on a scale from 0 to 100, all of a sudden that becomes less impressive. And I'm not saying that one or the other is better here. It can make sense to zoom in on your data visualizations in that case if you want to show something. Sometimes you can, like, an effect might still be meaningful even though it's small on the absolute scale, or small in relation to the range of the measurement that you had. So all I want to say is that you should be aware of your responsibility when you plot, and should make informed decisions of what you want to communicate, which is a nice transition to a couple of, I call them basic principles. That sounds like there's consensus around them, but it's mostly me reading up on data visualization and sort of condensing a couple that I find useful, sort of as a starting point when I think about how to visualize my data. One is, I used to play basketball, and there was there's one famous coaching system called KISS, Keep It Simple and Stupid. And that's something I often saw with bachelor students, for example, with a sort of desire to show everything that's in the data. So if all you want to do here is show a relation between X and Y, and you just happen to measure gender as well, then I would argue that the graph on the right-hand side is way more useful to communicate what you found or what you're interested in than the one on the left, even though the one on the left has more information. In addition, I personally don't like grid lines and backgrounds, so I would always advocate for keeping it as simple as possible and removing any like unnecessary parts of the plot. Then there is a big debate about showing your data, and I think that's something, maybe I should have been the first principle, that we should take to heart, which is ideally we choose visualizations that are as close to raw data as possible, so people can truly judge how distributions look like, whether they are outliers. There's a quite an influential paper here at the bottom from 2015. So the bar graph on the left is compatible, has the same mean and error bar or confidence interval as all the other, like the raw data patterns on the right. And I think in that case, I mean, it's not deceit or anything, but I think you could communicate this clearer by, for example, showing the raw data, and hopefully I can give you a couple of hints on how you might achieve that. There's even been a Kickstarter, was that 4.5 years ago, where a couple of scientists want to raise $3,000, I think at the time, to print those t-shirts and send them to journal editors to bar plots, because they thought that bar plots really shouldn't be used in scientific publications because they hide what's important. The bar plot is basically just the mean and standard deviation in visual form. And then you might as well just use the numbers. Then there's another one from, oh God, I forgot his first name. I think Edward Tufte, who's the grandfather, the pioneer of data visualization, at least one of them. And you're going to see that this is still from the 80s, so data to ink ratio, when you were still printing stuff, but the general principle still applies, which is to say, if you printed your graph, then most of your ink, what your printer uses, should be used for showing data, not other stuff. So the graph on the left has what's called a low data to ink ratio, because all the blues are necessary. I'd argue the grid lines are necessary. And the plot on the right has a high data to ink ratio, which sort of relates back to keeping it simple and stupid. Then another one that I often saw with students is, and again, relates back to the first point, you should know what you want to communicate. If I look at the left plots, so both plots are based on the same data, simulated data, by the way, just fake data. If I look at the left one, I see it in the paper, I would strongly assume that you are telling me about an interaction. You want to show me how a relation differs between two groups. Whereas the one on the right shows one of those variables and its distribution. So what you often see in thesis is statements like, if you have a look at figure 1, you can see that the distribution for that group was skewed. But if you present me with that sentence in the figure on the left, then it's really hard for me to see that. And that's just one of those, I mean, you should know what you want to communicate, and ideally you can write that down. Maybe write the figure caption before you, or at least get bullet points on the figure caption before you start visualizing. Another one that's quite important is your data should ideally be presented in your stats should be presented in proportion to the data and with correct axes. It's quite a cool example, again, with fake data from a blog, where we have the blue line, which is global GDP in the States, and the red line, global GDP in Germany. And if you present a graph on the left, it's one of those things, like a lot of data scientists strongly encourage, and that's just code for would like to prohibit, that we use two axes on the same graph, for example, because it's frankly misleading. They're completely different scales, and you cannot really gain anything from that graph if you intend to make a comparison. So in that case, you might want to get creative, transform your data, and turn it into a graph on the right side where you turn it into percentage change, so relative changes. And then I think all of a sudden you can see differences in how the GDP developed between those two countries. Last, ggplot gives you a lot of customization options. So I would always argue, especially now that we're in a time where printed journals aren't really that much of a thing anymore, and most stuff's online. Back in the days, you'd have to pay extra, a ludicrous amount for printing color figures. Now I don't see that as a problem anymore. So I would always prefer the plot on the right to the plot on the left. The plot on the left, it's really hard to see the difference between circles and triangles. and B, you just have no idea which regression line belongs to which group. On the right-hand side, that's intuitive. You can immediately match colors with the groups and the underlying data. All right. Then to the reason you hopefully hear, which is why R and why ggplot2. So I know this. If you talk to someone who's used R for a long time, there seems to be this almost like religious fascination with it. And I'm not going to say it's inherently better than, I don't know, if you've been trained on SPSS or Excel. You can do a lot of the same things with both. But I would say that the differences become quite apparent when it comes to plotting, just because ggplot is such a refined and useful, flexible tool for data visualization that you just cannot match with SPSS and Excel. You can do quite a lot with them, but not to the extent that you could use ggplot2. It's reusable in the sense of it's code-based, so you can always, if you want to get fancy, if say you use a graph, you have a research line and you get a lot of similar data structures, you could write functions for data visualization and even turn it into your own R package, into your private R package, load at the beginning, 2 lines of code call, and you have exactly the figure that you want. It's reproducible because you can share it with others. And I'd argue because you can repurpose parts of it, it's extremely efficient. Also, ggplot2 is the de facto standard for our users. I'd say 95% of people use, at least for like common data visualization. It's not as good in 3D stuff, for example, but I'm not the person to speak to that because I haven't done 3D plotting yet. It's extremely flexible, highly customizable, and I hope I can showcase that at least to a degree. And what's so nice about it is that it has a consistent underlying logic in creating graphs. Even though it might be a bit confusing in the beginning, in the long run, you're going to become better. You're going to become better and better at reading, for example, other people's code, because it follows the same logic, which is the logic of layered grammar of graphics, which I'm going to talk about. It's quite nice because it gives you full control over the output that you're going to produce with your plots. So you can really have publication level output with a high degree of, or with a high resolution in the size that you wanted. What's extremely nice about it is the active user base. And I am certain, I'm far from the first person to give an intro to ggplot2. If you just Google that, there's going to be pages of search results of people who've done similar stuff. And the nice thing really is that any question, especially as a beginner, you have, or you might have, someone else has had before you. And I know that's the case for a lot of coding, but for ggplot especially. I think the first 2 years that I used ggplot, I could never remember how to remove a legend, for example. And that was, I think in 2018, that was my most used, you know how Google shows you how often you visit the site? That was my most used Stack Overflow page, because I just always had to return back to that page. Right, and then last, it's just personal, but I think you can just make really pretty graphs, prettier graphs than you could do in SPSS or Excel, for example. And I can't really speak to MATLAB or Stata because I haven't used them really, same with Python. But in general, a lot of journalists, or I think 538, for example, uses ggplot2 as well, and they make really pretty graphs. Sometimes you're surprised from what you're going to see now, how that can evolve into something that's quite cool. All right, then the go-to resource, if you really, again, this talk is just a primer. If you really want to get into ggplot2, then I recommend reading the book by the man who developed ggplot2, Hadley Wickham. Good thing is the book is free, not the paperback. I think that costs 10 or 20 pounds, but the link here that just links to the online version, which I would prefer because it's updated more frequently. Right, so what is this grammar of graphics that I talked about? And this is going to sound really abstract, and I hope I can make this more concrete in the rest of the talk. In brief, this is an excerpt from the online book. It maps data to aesthetic attributes of geometric objects. So it assigns, say, variables in a data set to something that we can visually perceive, such as color, size, or shape, of a geometric object, which could be points, lines, bars, etc. And again, it sounds abstract right now, but it has the huge advantage that it allows you to iteratively update a plot, changing a single feature at a time, which, especially as you as you begin data visualization is extremely helpful because you don't have to change multiple things and then don't know, a bit like an experiment, which parts of your changes is responsible for which change in the graph. And we can make the point that this shortens the distance from mind to paper, and I hope I can showcase that at least to some degree in the next couple of slides. So this, I know this can look intimidating. It certainly was for me at the beginning, and I'm not saying that the learning curve is flat here. I think you can plot relatively quickly if you just copy paste, but to understanding that grammar or just how ggplot2 functions, it can take a little while, but I'd say it's definitely worth it. So the basic idea here is that you can think of the layers as building blocks for your plot. So you have your data, then you have a mapping, aesthetics, where you just tell ggplot which part of the data belong to which aesthetic property, such as color. Then you have a scale, which is often axes. The geometric objects, which you actually see, ggplot can compute stats for you. It can facets or create subplots or different panels of a graph, and you have the coordinate system. And you can combine and shuffle all of those to create maybe any kind of graph you want is a bit strong, but like really possibilities are immense. The nice thing about this is that the use of these layers is hierarchical and logically consistent. That's the whole point of a grammar. And I hope that's going to become a bit clearer. So just to go through those through those blocks before I show you how they look in practice. So we have data, and I'm sure data scientist has a better definition for what data are, but in my mind, observations organized as variables. Then you have an aesthetic mapping that maps a variable in the data to an aesthetic quality or property of the graph. In that case, for example, you could say that colors should be assigned according to a variable. Then you have scales that implement the mapping, which is just abstract of saying turning values in the data into values in the graph. For example, how groups get assigned colors, how to create axes and legends. Then you have the thing that you actually see, geometric objects, short geoms, that's how they call it in ggplot grammar. And that just turns, that's what you actually see, that turns values in the data into, for example, points. That's the stuff that actually happens in your coordinate system. Then you can have ggplot summarize and transform data values for you. There's functions for that. You can split up the graph into displaying subsets of the data. For example, in time series analysis, if you want to have a panel per year. You have a coordinate system, and then you have themes, which I'm not really going to talk about that much, but I encourage you to just Google ggplot2 themes, and you're going to see this is all just aesthetics in the sense of making your graph look a certain way, which can be quite cool because there's people who have created themes to make them look like from a certain journal, for example. All right, then let's go through those layers, which like any talk on R will always use the built-in data set. In this case, the empty cars data set that comes with R. You really don't have to understand what's going on here because I don't either. I know that, like what some of those variables mean, but I'm not a car guy, and it's just for visualization. It really doesn't matter what we choose here. So, like the very first step is we tell ggplot2, and notice that it's ggplot and not ggplot2, the call. We tell ggplot what data to translate to a graph. And if you run this command, so like on the left, I always have code, and on the right, I always have what happens if you run that code. Then nothing's going to happen. And that's good because all we did right now is tell ggplot, hey, this is the data. These are the data that we're talking about. Only then do you go to the next step. And you can see something happens on the right. We tell ggplot2 what variables we want to map to aesthetic properties of the graph. And aesthetic properties here is just a fancy way of saying we assign variables to the axes. So in this case, miles per gallon to the x-axis and displacement to the y-axis. But you'll notice there's still nothing on the graph. And again, that is by design. Because at this point, all we've done is tell ggplot what data to use and how these data should be mapped to aesthetic properties of the graph. And that's exactly what ggplot does. It follows our commands to the letter because it creates an x and a y-axis, but it doesn't fill it with anything because we haven't told it yet to fill it with anything. That's what we do in the next step. And here you can see the little plus sign. you can see how the grammar of graphics and this iteratively updating comes into play. Because now we added geom. We translate the mapping that we did into something we can see, in that case, a point for each XY combination. And you'll see that geom point, we're not giving geom point any arguments, because geom point knows from our initial call, from our static mapping. I know whether you can see highlights of my mouse, but from the aesthetic mapping of the axis, it knows that it has to display XY combinations, points for XY, because we already told ggplot what should be on X and what should be on Y. And as a next step, for example, for faceting, we could now, and again, there's just a plus sign, so it's iterative. Like this is the same code as the previous slide, we just add one more component. In this case, the component is that we want to facet the plot, which in that case just means we want to have separate panels for a level of a third variable. In that case, the variable is the number of cylinders a car has. So we have an XY plot, again, that it takes that from the aesthetic mapping for 4, 6, and 8 cylinders, which is just a different way of displaying the data we had previously. All right. Again, you'll see another plus sign here, and we could. I think once you grasp that point, that makes it easier to get into a logic of ggplot. We can add another geom. In that case, just a regression line. And you'll notice here, so the geom is called geom smooth, and we have to tell it what method to use. In that case, a linear model that just gives us the OLS regression line. But you notice that we don't have to tell geom smooth what data to use. Again, because just like geom point, it inherits the mapping from our aesthetics call. We don't have to tell it, hey, regress Y on X. It knows that because we in our initial call, we did specify X and Y, and both geom point and geom smooth inherit that mapping. All right, then let's get to a point that always confused me when I started, and I hope I can help you get over that confusion. Let's add another aesthetic. Here we tell ggplot2 that we want another variable mapped to a separate visual property. In this case, not one of the axes, but colors. So what we tell ggplot is, hey, this miles per gallon should be in the x-axis. Displacement should be on y. And whatever happens afterwards, whatever geom we use, color those geoms, color those geometric objects according to the value that is a cylinder. And if you look to the right, that's what happens. We get blue points for 8, green points for 6, and red points for 4. And this is where, at least when I started, made most of my mistakes, because I didn't really understand the aesthetic mapping. What I did was, instead of, if you compare those two code chunks, instead of using color, assigning color to a variable in the aesthetic mappings, I just thought, okay, there is a color argument for geom point. I'm just going to put it in there. And what happens then is what you see at the bottom. You're going to get an error. Why will you get an error? Because the color argument inside geom points expects a color. What we're saying right now is what we're saying here is all points in this geom should have the color sil, but sil is not a color. Pink is a color. So as you can see, if you put in pink, then what happens on the right, you get pink points. We're not saying map the colors in this variable, map the values in this variables to different colors. So it's not an aesthetic mapping, it's a constant. We're saying all points should be pink rather than color according to a value in a variable. We could remedy this by adding aesthetic mapping rather than for the entire plot, just for geom point. So here we can put this argument into a geom specifically, instead of specifying it for the entire plot. And that leads us back to the same graph that we had before, which makes it, I think once one gets behind that logic, it really opens up ggplot, because now color is not a fixed value anymore. It should be cylinder, by the way. Color is not a fixed value anymore. Now color is variable according to another variable, which in that case is the number of cylinders. To drive that point home, let's consider the previous example where we had color mapped to cylinders in the initial call to ggplot. We said effectively, everything that comes after this, every geom that comes after this should be colored according to the value in cylinders. And then you'll see if we add geom point, we get differently colored points. And if we add geom smooth, we also get differently colored regression lines, one for each level of cylinder, because it inherits that mapping, that color mapping from our initial call. So what happens if we mix this up? Well, here we did an aesthetic mapping, but only for points. So what we're telling ggplot, that's the only place within geom points where the colors are assigned. But because we don't have that mapping, it cannot inherit it from anywhere for the regression line. The regression line will not be colored according to cylinder. It will just be like the default color that ggplot chooses. So what happens then on the right is we didn't tell ggplot to anywhere that line color should be mapped to a variable, should be mapped to cylinder. So what we get is we get colors per point for the geom point, but we do not get separate regression lines. And that might be something that you want to do. And I'm going to return to that, back to that in a bit, why that might make sense. Because now you might ask yourself, why wouldn't I just always have it inherit this? So here we could remedy this again by individually specifying for each geom how the color should be mapped, or that this equivalent to just doing it for the entire plot, where we assign it and all the geoms afterwards inherit that assignment. And in a couple of slides, I'm going to tell you why that makes sense, why we would do that. But first, let's talk quickly about the scales layer, which is just a way of, let's say, customizing your plot a bit. So in that case, you can see the highlighted parts. In a paper, you will probably want to, or you definitely want to have proper axis names, in that case, miles per gallon displacement. And I set arbitrary limits here, like the limits where I thought the data looked best. But usually ggplot automatically scales to see the full data. That can have advantages, but can also have disadvantages. Think back of the early example where I showed you those two bar plots between the control and the treatment condition. If all your variables, say in the treatment condition, everyone was between 30 and 40, and same in the control condition, then ggplot will just assume automatically for you that this is about your data range. And that might be one of those cases where you say, okay, I'm going to set the limits manually. I'm going to set it from 0 to 100 because that's the true data range. It just happened that none of the participants scored in those extremes. If you do that, always look for warning signs. In this case, I did something very dumb. I set the limits very, very tightly, such that only 3 points that you can see in one of the quadrants here have been retained. ggplot will warn you. It will tell you, hey, by scaling so narrowly, you removed 29 rows containing data. So it's something to keep in mind. Then, of course, there's the stats layer, the second to last layer. And that can be useful, I'd say, for simple plots. And here, for example, we tell ggplot that we want to see the average value of displacement for each of the 3 cylinder types. What we do is, instead of adding a geom, we add a stat summary. So we tell it, all right, our function for displacement should be mean. So give us the mean for displacement, and as a geom, please choose bar. But you could fill in anything that you wanted here. You could also fill in points, if you wanted points instead, or lines. So in that case, you let ggplot to do the work for you, which, again, for simple graphs, I think makes sense. Later on, I don't know, I'm generally not a fan of this sort of black box approach. I'm going to show you why. But first, yeah, so you can also have ggplot calculate error bars for you. In that case, you just add another geom or another component of the plot, which is another stat summary. You tell it to please calculate for you, that's the mean CL normal, the confidence intervals of that mean. You tell it which geom to use, an error bar, and the width is just for aesthetic purposes, so the error bars don't get too wide. Again, this totally works for bar graph and for simple stuff. In general, maybe it's because I'm a control freak, but I prefer to do this myself, in the sense of I prefer to calculate summary stats myself and visualize them directly with ggplot. So if you're new to R, you don't need to understand what I'm doing here with the code on the top. What's important is that there are ways where you can just take the data set, this data set that we feed to ggplot, Mycast, at the top. And we can calculate from that our own summary stats. So if you look at the bottom, that's the entire data set. That's 4 columns, 3 rows, where we have the means for each group, and we can calculate the lower and the upper bound of the 95% confidence interval ourselves. And then we don't need to rely on ggplot to summarize stuff for us. Instead, we can just tell it, hey, instead of using Mycast, now use my stats. And instead of calculating stuff for us, use a geom bar, and on the y-axis now is our self-calculated mean. Because that data set also contains the error bars as separate variables, CI low and CI high, we can feed those to ggplot in a geom error bar. We can tell it, hey, the minimum on the y-axis should be that, like the lower bound, the maximum on the y-axis should be the upper bound. And that way we can, rather than relying on a black box and having ggplot calculate for us, do it ourselves, which has the advantage of you having to check your summary stats rather than just plotting something and thinking, okay, that's it. Why would we do that? Well, remember the principle of showing your data, because that allows us to show both raw and aggregated data. And this is really where the grammar of graphics has its strengths. And I'm going to show you why. So we can start off like we did in the first couple of slides with the Mycast dataset. That's the dataset that contains the raw data. And instead of using a bar, this time use geom points. And as you can see, we get the points for each of the 3 cylinders on the right-hand side. And probably because a couple of them overlap, I decided to just jitter them a bit. There's an argument for that. And now comes, well, I don't know whether it's cool, but I think it's cool. Comes the cool part. Now we add another geom, but it doesn't refer to the same data set. Rather than referring to raw data, this one refers to the stats that we calculate ourselves. And this is really where that's one layer on top of the other. We have like one layer with the original data set, and then we add another layer with information from another data set. In this case, the data set that we calculate ourselves. So here we have our stats. We tell it, hey, the cylinder is the same. That's on the x-axis, but this time use the mean, please, and color according to cylinder. And I don't know whether you can see the difference. I'm going to make that clearer in a bit. If I'm going back and forth, you can see 3 points disappearing, and those are the means. So it added means as points in there. And to make them more visible, we could also again refer to our summary data set and add the lower and the upper bound of the 95% confidence interval. And I'd say if you now also make the mean points a bit bigger, we make the plot a bit prettier. I'm not going to go through the code. I'm not saying this is publication ready, but I think this communicates what you want to show, which is what the whole bar plots movement was about. You show the raw data and you show the summary stats, including the uncertainty. Then quickly, R is an object-based language, and ggplot2 is no exception. That can really be a time saver. For example, we can assign a first layer to an object. In this case, we call the object layer 1. Afterwards, we can call it, just type it into a console, and what happens on the right is what's going to appear. That has the advantage that we don't necessarily, if you make like the same plot for multiple data sets, for example, or we do this with several variables, you don't always need to type out everything again or copy paste your code. Instead, you could just assign the geom point to a second layer, and then at the bottom here, just say layer 1 plus layer 2, and that's the equivalent of what we've been doing on the first couple of slides, and that just produces the plot on the right. If you now wanted to change that, you could assign a different geom to layer 2, and then make the exact same call, and you'll see that you don't have to type out what's in layer 1 again. That allows you to recreate previous figure with a different geom, and in a sense, everything that comes after a plus sign, every component can be assigned to an object, which will probably at some point get you into thinking about maybe writing functions for graphs that you use a lot, or not having to copy paste a lot of code. Cool. So you can see we assigned our figure here to an object called our figure, and we can easily save that one. ggplot2 comes with a ggsave function, which is extremely handy, because if you've ever submitted something to a journal and got the proofs and have seen that the results or the figures were extremely distorted, They can be quite frustrating. And I'm not a graphics designer. I don't know. Whenever they tell me something with DPI, I just fill in a number and ggplot does it for me. The same with height and width. You can use it in different units. Instead of inches, you can use centimeters or pixels. And that's quite a time saver. All right. Like 20 more minutes. Okay, I'm going to try to make this quick. This is not meant to give you any like a how-to of how to do stuff. I just want to give you a couple of examples of how I use ggplot when I visualize data, especially distributions, to like from useful to pretty. Let's call it a continuum. One is just histograms, and just like previously, histogram is just a geom in ggplot. So if you can see, that's the second component that we add on the left. I fill it with a color that I like personally, but you can fill in any other color, give it a couple of like meaningful axis names, apply my favorite theme, which is cowplot. And I think the one on the right, that's already quite pretty. You don't have to put it in the paper, but if you have it in the online supplementary materials, that's helpful. So just an example how, and all credit here goes to my colleague Matti Fore, who is a database. For example, here, like he convinced me that it doesn't make a lot of sense in your method section to have a measures subsection, but for each measure you say we measured self-esteem with the Rosenberg self-esteem scale. Mean equals that, standard deviation equals that. I've come to the point where I prefer to put as few numbers into the text, into the prose of an article as possible, and try to show everything else as figures. And I think this is much more informative. Here we have two variables, never mind what the game is. And as a reader, you can immediately see the little triangles at the bottom show you the mean. And you can gauge the variation around the mean from the histogram, which I think is much more informative than having just a simple sentence with player well-being had a mean of 2.4 with a standard deviation of X. Because it's more, I think it's closer to show, don't tell. Then another classic is a density plot. Again, that is just a simple geom call in ggplot. That's the color I like, but you can fill in anything else. You could then specify, for example, if you want to show distributions of separate groups in experiments or distributions of separate variables, you could then color and fill by a third variable, which results in the plot on the right, which I think is already quite informative if you want to have a look where mean differences come from. Is it really a shift of the same distribution, or is it because, I don't know, say one group was more skewed than the other? You could again facet this, so give one panel per group, which can also help. Or what I consider one of the prettiest ways to show distribution is the ggriches package. Especially if you have a lot of variables, it looks quite nice if you have them on top of each other. And if you want to get fancy, you could even say, well, you also want to show the raw data, right? So maybe you can add the, or you can add like another geom for the mean and the standard deviation here. One problem that I see with this, or not problem, but if you, for example, look at the top one, at the green one, and there's a little bump to the left. And close to the principles of showing your data, I prefer to, if the data set isn't too huge, for me right now, it's not clear whether that little bump means 5, 50, 5,000 data points. Is it one outlier? Is it a couple? Is it even an outlier? And that you cannot really gauge that from this figure. So that's why I like the bswarm package, because it sort of does both. It's arranged in such a way that it gives you an idea of the distributions. And again, you'd need to install a separate package here and then call the bswarm function. And you can see that with very little code, I'd argue this already quite pretty and tells readers almost everything they need to know. It shows them the raw data points, and you can see at the bottom that little bump was indeed two data points, not 20. So that's quite informative. But you can take this a step further if you wanted to. So how I use bswarm plots is mostly in papers. This is from an example of a paper that's currently under review with TUI, actually, where we decided to display all our descriptive information and a figure all in one place. And as you can see, there's also text. So there's mean and standard deviations and the reliability coefficient. I think that's I'm not saying that's the end all, but I'm quite happy with this just because it shows the distribution, it shows raw data points. Readers can immediately tell, hey, is there maybe one or two data points that pull your mean away from a theoretically normal distribution, for example. And you can add what's called a geom text to add those little text boxes. I prefer this for visualizing or for communicating descriptors of my sample over having it in the measure section, where I just include a mean and a standard deviation. Speaking of showing distribution and raw data, this is sort of where all the hype is right now. Rank cloud plots. I think that came up like 5 years ago and has now been made into an R package. So you would need to install library rank cloud plots, and they're not as straightforward as the rest. Requires a lot of coding to get them looking nice, in my view. So check out that link. I mean, on the one hand, I really like them because they do give you explicitly the density function, plus the raw data, plus box plots in this case, plus even showing you, this is from a pre-post test design, how individual participants developed or how they changed. However, it can get quite cluttered, especially if you have interactions. If you turn this into a 2x2, I'm not sure it's still like the plot. You don't want to overburden readers with just showing all the information that's there. But that's my personal opinion. If you really like them, I've used in publications, and I know a lot of people are quite fond of them. So I'm not trying to down talk here. I'm just saying, like, have your readers in mind as you make your plots. I've used them from the same project here. That's again for just showing descriptors of the sample. And there I'd say that rank clouds are extremely useful because you can show the distribution, you can show the raw data, plus the mean. You can see it there somewhere between the data points, between the rain and the cloud, to show the average of the sample. So I think for that, it's quite useful. I'm a bit more skeptical when it comes to visualizing experiments that have more than one factor. All right. I'm going to skip this part, but I'll share the slides because I already talked way too much. Just a quick shout out to people. As I said, there's so many tutorials on ggplot2 online, but Philip Mazur and Jeffrey Gerard recently gave intros, and I was heavily inspired by those. Right, that's it for me.
Thanks so much. That was super interesting and really helpful. So we have about we have a little more than 10 minutes for some questions and discussions, or any input from anybody. I'll start off with just a quick question for you. We were talking a bit before we started about reasons why we used ggplot. I mentioned that was what got me started in R programming in ggplot, just to make a nice graph. So do you recommend if people don't have any background with R that this is a good way to get started, or a good reason to get started?
A good reason, yes. A good way, I'd say no. Just because, I mean, I do think that ggplot is really a great way to visualize stuff. Otherwise, I wouldn't be here. But as you can see, if none of the, like if the code scared you a bit at some point, if you're completely new to R, then it's probably better to get a 1 or 2 day crash course on how R works before you get into this, because it can get quite frustrating. I mean, I talked about bringing the data into a format that you need, and ggplot has format requirements for your data. If you don't understand those, if you don't know how to get to just like manipulating, I shouldn't say manipulate, to wrangling the data into a form that is needed for visualization, and then you're sitting there and you don't know why it doesn't do what you want to do. So I'd say ideally start with R a bit. You don't need a lot, but a bit of base R, I think that can be learned in a couple of crash courses before you move on to ggplot. But how was it for you? You started with ggplot then?
I did, yeah. That was really the impetus to get started, just to make a nice violin plot. I had some split violin plots with like time 1 and time 2 on different halves, and it was really complicated, as you mentioned. It took me a long time, but it really got me motivated to learn more about R, just in general skills. So We do have a couple questions coming in. So let's see, what about color use, especially for people who might have vision impairments?
Yeah, that is Eden. Let me quickly, it is somewhere in the slides and I'm going to post it back into the chat. There's a link with 2 color palettes that are like for colorblind people. And that's where I usually draw. But when you saw those, like with little like hex formations for colors, like the hashtag and then a couple of numbers, I just got them from that link. I just posted in the chat. It's something that I wasn't aware of until, I don't know, like embarrassingly recently, that colorblind people will not maybe appreciate the colors that I choose personally. So I recommend to choose from those that you have quite a wide range. And it's nice to know that everyone can see the differences.
Cool. And there's also, I've come across recently some different color palettes available in R that do different things. So like colors that are black and white friendly for printing in paper, that will still show different shades of gray, and then all sorts of different fun color schemes. Have you ever used them, like the Wes Anderson color scheme or anything like that?
Yeah, of course. I think everyone has to, right?
Right.
It's part of the fun. No, there's really so many creative people out there who do themes for you. And it's just, sometimes just fun wasting half an hour just applying different themes and seeing what happens.
Of course. Another question. Thank you so much. I'm very new to URX. So what's the best way to start learning ggplot and R?
Cool. I'd say starting with R is, I'd start with, I mean, the two are linked, right? But I'd start with R in general. And let me quickly fire up a Google search. Hetty Wickham's data science, what is it, R for data science? R for data science. If I find it, I'll post the link. Yeah, there we go. I think that's really a nice way to get started. It's quite comprehensive, but it is a free textbook that's updated a lot. And I think Danielle Navarro, she also had, it's called Robust Tools. Yeah, she put her data science with R class online, and I think she does some of the like nicest, like gentle intros to R. Wait, I'm also, there we go. They're both in the chat. I think those are really good resources to get started, and it's also just cool that it's open source. Plus, I'm going to post another one from having done a postdoc at Glasgow Uni, because at Glasgow, Lisa DeBryan and Dale Barr created a course for their, I think it's for their master students, but might also be for their bachelor students, so correct me there, where they start with data science principles before they move on to actual stats. You can't see any of the chat.
Oh, I see. Let's see. I can copy and paste these to everybody really quickly. Yeah.
Oh, yeah, it's my mistake. I posted it to all panelists. So there you go. Instead of all panelists and attendees.
There we go. I didn't even know that option was there.
Yeah, neither did I.
Yeah, the SciTeacher materials from Glasgow are super helpful.
Yeah.
And I think they do start at undergrad and go all the way up.
Yeah, which is quite rare. And you know, you always hear the argument of saying it's too hard for undergrads, but I think that comes from people like us who learned coding quite late. I wish I'd had coding in my undergrads, because it's not like your brain has to develop until you're 25, and only then can you be confronted with code. So I mean, I guess the earlier you start, the better.
Definitely.
There's also a question in the chat from Maya, John. So, because I know that
what would you recommend for interactions, let's say a 2x2, and what are the prettiest and easily interpretable options?
What in the past, I've used violent plots, but I'm not sure that is you should do this. Ideally, you just have a look at the different geomes and decide for yourself, like play around with it. I mean, that's the cool thing, that you just need to change a couple of lines. It really depends. I mean, if you have very little data, then let's say, for example, like the B-span plots showed, if you just show 2x2 and maybe connect the means with the lines, so you can see trends, that might be enough. If you have a lot of data, I've done that in retrospect. I did a rain cloud plot with an interaction. and that was just too messy. So that's what I mean with you have to make decisions about like how close do you stay to your data. If the data set is massive and you have, I don't know, 2 million data points, then it's probably not a good idea to show all the data, but you need to make a responsible decision about how to aggregate and show that. And I'm sorry that I don't have a more definitive answer there.
I'll add just a little bit to that. This isn't about ggplot, but there is a package called interactions, which if you look around, you can find packages for anything. And I sometimes go back and forth between the interactions package because you can add ggplot arguments on top of it. So there's another question in the Q&A. Sorry if I missed it, but how do you set a specific color to the whole figure when you assign a color to a variable? In your example, it was cylinder.
Oh yeah. I mean, it's a bit abstract to talk about code there, but remember in one of the earlier slides when I talked about aesthetic mapping, you can set a constant color by just for each geom saying color equals whatever you want to do, black, blue, green. And if you set it within the geom, then it will be the same color for all groups. I hope that makes sense. I mean, it's always a bit strange to explain code without actually showing it.
But we will link the slides and the recording of this video and the code and everything on there, so you should be able to go and follow along as well.
So there's one question in the Q&A from Haley.
Oh, that was the one we just talked about.
Yeah.
Okay.
So there's also a lot of other options for different kinds of plots that can get pretty complicated. So for example, mixed models where you have multiple time points and you can plot different predicted lines and distributions for each individual subject. Have you ever used these more complicated options?
Yeah, that's. I don't know whether I'm a hypocrite there, but I tend to try to make it as simple as possible. I mean, that's my personal belief that mixed models in the end, what you're interested in is to fix, so the average effects. So that's what I plot. Not necessarily. I know there's also people who want you to show the overall slope and then each random slope, and I think that gets messy with a large sample. It can be informative. I don't know. I guess if you're someone medicine and you really want to avoid anyone showing a reverse effect, then it's probably cool to show that. But even then, maybe not with lines, but rather extract. It's in the like the part that I didn't get to, but how to model regression results. That I think that applies to mixed models similarly, because you can extract the coefficients and just use that as data points, for example, a line plot. And I think that's more informative than overwhelming people with data. But I'm not saying I have the golden answer here. There's probably as many people or even more that disagree with me as those that agree with me.
I think for me, it was kind of like an epiphany, I guess. I mean, when I started thinking about data in R and all these different ways to plot it, I thought about all the different ways I can analyze things and show people my results, and it really just helped to sit down and play around and just really think outside of the box. There's so many things that you can do that I never would have even thought about. So yeah.
I completely agreed. I think in the end it's just play with it. That's one of the cool parts once you start getting the hang of it and you just say, I'm going to do something that's maybe a bit unconventional. That's really when that's a good day in the office. if you go home and thought like, I think I made a plot that's exactly what I wanted to show, even though it might not be standard or canon in the psychological literature.
And it's a good distraction too. I've often found sometimes I'll sit around for several hours and just make graphs, and it's so much fun.
Productive procrastination.
Yeah.
If I have something that I don't want to do, I just do a plot instead and tell
Right.
myself at the end of the day, hey, you did something.
There you go. Well, that's just about our hour.
Cool.
Yeah, so thanks so much for this talk. It was great to have you. Nice to meet you. And thanks for the questions, everybody, in coming. And as I mentioned, all the recording for this and all the materials will be posted on our OSF page and on the GitHub page. So check those out, follow along with the code, and then of course, reach out to us if you ever have any questions.
Cool.
We'll stop
All right.
recording.
Thanks for the invite, and goodbye, everyone.